Every second your brain takes in visual information from the world around you. It processes that data and then creates an experience of reality that feels as real as can be. So here's a question for you. Are you seeing the world as it really is? The answer might surprise you. You know those classic optical illusions that have been doing the rounds on social media lately? Well, they are more than just tricks of the eye. They actually reveal how your brain constructs your perception of reality. And it does so with a few simple rules that I want to take you through right now. So let me introduce you to the grand delusion. If you grew up in the late 90s and early 2000s, you probably remember this cartoon called The Fairly Odd Parents. One of the characters, Mr. Crocker, was obsessed with fairies and believed that they were real, despite everyone else thinking he was crazy. He was even willing to believe that his own wife was actually a fairy in disguise. There's a character in the show called Cosmo who looks like this. And whenever Cosmo would appear, Mr. Crocker would say, "Cosmo, Timmy, fairy godparents, pinch me, I must be dreaming." And every time he said this, Cosmo would respond by saying, "This isn't a dream, silly, this is reality." But the interesting thing about this quote is that it is not only true within the context of the show, but also in our real world. Neuroscience has recently revealed that everything we see and experience is actually a construction of our brains. Everything we see is first processed in our retinas and then sent to the brain via the optic nerve. That signal gets processed in the occipital cortex at the back of the brain before getting sent to other parts of the brain, so that we can interpret what we're looking at. At each stage of this process, various shortcuts and estimations are made. These allow us to quickly process the incoming data without having to calculate everything from scratch every time. The thing is, these shortcuts and estimations often result in inaccuracies and illusions. Basically, the world we experience is a kind of lie that our brains tell us in order to make sense of reality more quickly. Welcome to the grand delusion. Let's start with some basics. The world we experience is full of missing information. For example, when you look at a painting, there is no information in your visual system telling you exactly what color each individual pixel is. Rather, your brain uses estimations and educated guesses to fill in these blanks. If you look at this image long enough, you will start to see that it is not actually made up of individual pixels, but rather it's made up of patches of colors that our brain has grouped together. Each patch is called a perceptual grouping or a gesture. Neuroscientists studying visual perception use algorithms to model how the brain groups these features together. Those models have revealed that there are four main strategies the brain uses to group features together. These are called the proximity, similarity, closure, and continuity principles. The proximity principle dictates that we group objects together based on their physical closeness. The similarity principle states that we group objects together if they are similar in color, shape, size, orientation, etc. Closure refers to the tendency to complete incomplete figures. And the continuity principle states that we tend to perceive objects in a continuous fashion rather than in a fragmented way. These principles work together to help us organize the visual world into meaningful groups. For example, when you look at this image, your brain uses these principles to group the individual dots together into three separate clusters. Even though there is no actual physical connection between the dots, your brain still perceives them as being connected, because they are close to each other: proximity, similar in color, similarity, and continuous continuity. So this is how we go from seeing a bunch of random dots to seeing three distinct clusters. In essence, our brain takes the raw data from our eyes and fills in the blanks with educated guesses and estimations. The amazing thing is that this process happens so quickly and automatically that we don't even realize that we're redoing it. We just see the world as if it were a complete and coherent whole. Let's move on to something a bit more interesting. Our perception of reality is not only influenced by the information that we see, but also by our past experiences and expectations. A great example of this is the Muller-Lyer illusion. In 1899, German psychologist Franz Muller-Lyer presented two lines of equal length to participants and asked them which one was longer. Overwhelmingly, people reported that the line with the inward-pointing arrow tails looked shorter than the line with the outward-pointing arrow tails. Today, we know that this is not because of any physical property of the lines themselves, but rather because of our brain's attempt to interpret the lines in the context of the environment. The inward-pointing tails give the brain a sense of depth and make the line look like it S receding into the distance. In contrast, the outward-pointing tails give the brain a sense of depth and make the line look like it S coming towards you. So because of our brain's attempt to interpret the lines in the context of our environment, we perceive them as being of different lengths. Another illusion that plays on our past experiences and expectations is the Ponzo illusion. In this illusion, two lines of equal length are presented, but they are placed against different backgrounds. On one side, the line is placed against a background of parallel lines that give the brain a sense of depth. On the other side, the line is placed against a background of converging lines that give the brain a sense of perspective. Because of this, we perceive the line on the side with the converging lines as being much longer than the line on the side with the parallel lines. And while those two illusions demonstrate how our past experiences and expectations can influence our perception of reality, the next illusion demonstrates how our knowledge about the world can play a role too. If you stare at this orange dot for a few seconds and then shift your focus to the white background, you will see a green afterimage of the dot. This happens because your brain is trying to make sense of the information that it's receiving. Specifically, your brain knows that the human eye can only perceive a limited range of wavelengths of light. So when you look at the green dot, your brain assumes that there must be some light waves that are outside of the visible spectrum, like ultraviolet light, that are hitting your retina. So your brain starts sending signals to your visual cortex to interpret the missing wavelengths. When you look at the white background, your brain continues to send these signals, resulting in a green afterimage. What all of these illusions have in common is that they reveal the limitations of our visual systems. They show that what we see is not an objective representation of reality, but rather a subjective interpretation of reality by our brains. Now let us talk about something that many of you watching this video right now will find even more interesting than illusions. You know that scene in The Matrix where Morpheus asks Neo to choose between a blue pill and a red pill? Well, it turns out that our brains are capable of doing both. In other words, we can choose to either see reality as it is, or we can choose to see reality in a way that is more favorable to us. This ability is known as the placebo effect. In 1996, a study was conducted in which participants were given a sugar pill and told that it was a painkiller. Some of the participants were also shown a video of other people reacting positively to the pill. After taking the pill, participants reported a significant reduction in pain. What's interesting is that this effect was not due to any physical property of the pill itself, but rather it was due to the participants' beliefs about the pill. Specifically, the participants who were shown the video of other people reacting positively to the pill were more likely to report a reduction in pain. This is because their brains had created an expectation that the pill would work, which in turn made it more likely for their brains to interpret the placebo response as being real. Essentially, our brains are constantly making decisions about what to believe and what to ignore, and these decisions are based on a variety of factors, including our past experiences, our expectations, and our knowledge about the world. In other words, our brains are constantly constructing our perception of reality. Finally, let's talk about the last concept that makes up the grand delusion: cognitive biases. These are systematic errors in thinking that occur because of the way our brains process information. One of the most common cognitive biases is confirmation bias. This is the tendency to seek out and interpret information in a way that confirms our existing beliefs. For example, let's say you believe that women are better drivers than men. You might be more likely to pay attention to instances where you see a woman driving well and a man driving poorly. You might also be more likely to interpret ambiguous driving behavior as being driven by male incompetence. All of this leads to a distorted view of reality, in which women really do seem like better drivers than men. Another common cognitive bias is hindsight bias. This is the tendency to think that we knew something would happen all along after it has already happened. For example, after the Brexit vote in 2016, many people in the UK felt as though they had known all along that the UK would leave the EU. In reality, it was far from certain whether the UK would leave or remain in the EU. Hindsight bias distorts our perception of reality by making it seem as though we knew something would happen when we didn't. So there you have it, the grand delusion. Reality as we see it is not an objective representation of the world, but rather a subjective interpretation of the world by our brains. Through illusions, the placebo effect, and cognitive biases, our brains constantly construct our perception of reality. We hope that you enjoyed learning about the grand delusion. If you did, please subscribe to our channel and stay tuned for more videos. Thanks for watching.